Hey everyone, and welcome. You know that world map you've seen a million times? What if I told you it's hiding a secret? A massive, planet-sized secret. Today, we're going to put on our detective hats and piece together a puzzle that totally changed how we see our world. Okay, so let's just dive right in. Take a really good look at this map. You see the continents, the oceans, it all feels so permanent, right? Like it's always been this way. And for centuries, that's exactly what people thought. But here's the thing. Some of the biggest clues to a very different past are hiding in plain sight. And that really gets us to the heart of the mystery. Have you ever just looked at it? I mean, really looked at the coastlines, especially South America and Africa? Doesn't it seem like they could just slot together? Almost like they're two pieces of a giant broken jigsaw puzzle? That simple little observation, well, that's where a whole investigation begins. All right, so let's get into our first big clue. We're calling this one, fittingly enough, the jigsaw continents. So this slide right here, it's a perfect example of how science works. On one side, you have a simple observation. The coasts of continents like South America and Africa look like they match up. Easy enough. But it's the interpretation that's the absolutely mind-blowing part. What if they don't just look like they fit? What if they were once joined together and have somehow moved apart? But you can't just stop there, right? Any good detective knows you can't build a case on just one piece of evidence. So let's follow the trail to our next clue, which takes us from geography right into the world of ancient life. Now, this one is a real head-scratcher. For years, paleontologists kept finding identical fossils of plants and land animals on continents that are now separated by thousands of miles of deep ocean. I mean, just let that sink in for a second. How in the world could a little reptile that only lived on land get all the way from South America to Africa? It's not like they could swim. It didn't add up. The map as we knew it just didn't make any sense. And here's the beautiful, simple solution. The moment you start thinking about the continents being joined, the problem just vanishes. They didn't have to swim an ocean. They could just walk across. The fossil trail suddenly becomes this clear, unbroken path across one giant landmass. Okay, so we've got the puzzle piece fit, we've got the fossil trail. That's a strong start, but let's find one more major clue to really lock this thing down. For this, we have to go way, way back in time to an ancient ice age. So geologists found these deep scratches carved into the bedrock in places like South America, Africa, India, and even Australia. These are classic signs of giant glaciers scraping across the land. But when you look at today's map, the direction of these scratches is just bizarre. It looks like the glaciers flowed from the warm ocean inland and uphill onto the continents. It just makes no sense. It goes against everything we know about physics. But watch what happens when we push those puzzle pieces back together. As soon as you reassemble the continents into one supercontinent, all those weird random glacial scars suddenly line up perfectly. They point away from a central point, showing a massive ice sheet at the South Pole with glaciers flowing outward just like they should. And just like that, the thing that was physically impossible suddenly makes perfect sense. Okay, we've got three huge, totally separate lines of evidence, and they are all pointing in the exact same direction. It is time to officially name our theory, the one idea that solves the entire case. All right, quick recap of the evidence. We have the jigsaw fit, right? The continents look like they connect. We have the fossil trail, land animals showing up on opposite sides of vast oceans. And we have the ice scars, these glacial patterns that are impossible on today's map, but make perfect sense on a supercontinent. So what single theory explains all of this? It's called the continental drift hypothesis. This is the big idea. The continents aren't locked in place. They were once all joined together in a massive supercontinent. You've probably heard of it, Pangaea, and for millions of years, they've been slowly drifting across the surface of the Earth. You know, it's really hard to overstate how revolutionary this was. It wasn't just some quirky idea. It completely flipped our understanding of the planet on its head. It meant the Earth wasn't the static, unchanging ball of rock. No, it's a dynamic, living, constantly changing planet. But for decades, there was one giant question that really stumped scientists. How? I mean, how could a solid continent possibly plow its way through a solid ocean floor? The original idea of continental drift was brilliant, but it was missing the engine. It took modern science to find it, and in doing so, they evolved the idea into something even bigger, the theory of plate tectonics.
And this is the answer. We now know that the Earth's rigid outer layer, the lithosphere, isn't one solid piece. It's actually broken up into these massive plates, kind of like the cracked shell of an egg. These plates are floating on a hotter, much softer layer of rock beneath them, and they are always in motion.
So how do they move? Well, it basically comes down to three main types of action. At what we call divergent boundaries, plates pull apart from each other, and new crust is formed from magma rising up. At convergent boundaries, they crash into each other, which can push up huge mountain ranges like the Himalayas. And at transform boundaries, they just grind horizontally past each other, which is where you get a lot of major earthquakes. And that constant dance, that is the engine we were looking for, the force that drives continental drift. And the most important thing to remember is that this isn't just ancient history. The plates are moving as we speak, right now, at about the same speed your fingernails grow. It's this slow, unstoppable force that is still shaping our world. Which, of course, leaves us with one last fascinating question. We know where the continents have been, but where are they going next? The puzzle of our planet is still being pieced together, one tiny shift at a time.